This is a video on how to answer questions on the AP Chemistry FRQ portion of the exam. If you haven't already, go to my YouTube channel, Mr. Muskeluk AP Chemistry, and check out the playlist, and you'll find that I have a playlist on how to answer questions on the AP FRQ section. There's quite a few good tips there. You'll find some things that will benefit you there. Well, let's go to question number 4. The last 4 questions on the AP Chemistry FRQ section, 4, 5, 6, and 7, are 4 points each. Typically, people only get about 1.5 to 2 points on the average for these shorter questions. There's even one question that was notorious for having an average of 0. But that's not because these questions are so much more difficult. I think it's just that students rush through them or don't have enough time to answer them. So be sure to go through my tips on questions 1, 2, and 3 so that when you do those, you've got time for 4, 5, 6, and 7. Either that, or you might take some of these practice tests and start with 7 and then move up and find out which works better for you. But let's take our first 4-point FRQ series of tips by answering this question. The question starts off with an important table. They give you the elements, in this case gold and palladium, which they're going to talk about in terms of white gold, and the atomic radius in picometers. You see they're almost identical, 135 to 140. In atomic radii, there's a little bit of variation in them because the atom itself is a bit fuzzy in terms of waves and how it interacts with things. So with only a difference of 5 picometers, these are virtually identical. One of the things that you should be aware of on the AP exam is there's always questions on sizes of atoms. So you should know the trends for atomic size. I have a series of flashcards that I have for my students in my class, and one of the important flashcards is this one, flashcard 64 and 65, and there's a few others here, and it talks about the trends in atomic size. The gold and palladium are what they're talking about in this problem are in this area, and as you can see, these atoms are pretty much all the same size, but you really should know the trends and why atomic size changes. This question is about gold and palladium, and are right here. Here's gold and here's palladium next to platinum, silver, rhodium, ruthenium. All of these are used for jewelry, catalytic converters, pretty expensive materials. You didn't have to know about them here on the periodic table, but it's sort of nice to realize that we're dealing with these precious metals here. Let's read the question. White gold is a common alloy of gold and palladium that is often used in jewelry. Well, a little aside here, because, I mean, who just wants to deal with FRQs? It's nice to know some of the chemistry behind it. Know about gold already, but palladium is sort of an interesting one. It's been used more recently in jewelry. It's been used in catalysts for a long time. It has this silvery color, and its price has been going up and down, sometimes more than gold and sometimes less than gold. It's pretty inert, which is one of the nice things about it. It has this pretty silvery color. In fact, that's why people will very often put it in jewelry. You end up having rhodium, which used to be used to make sort of a silver-like lining on gold. But recently people have been alloying gold with palladium to get this white color. And here they've got the 2 colors that you get, and they compare them at this jewelry site where you've got 14 karat and 18 karat. The carat refers to the purity of the gold. The gold, when it is 24 karat, or now it's very often referred to as 999, is 99.9%. 18 karat is 750, or 3/4. So carats are generally, in terms of gold purity, are 24ths purity, not to be confused with the carat that's used for diamond weight. And 18 is 75% pure gold, 14 is about 58%. So that's what they're talking about when they're talking about 18 karat gold, the rest being palladium, and 14 karat. And they get different undertones, and they sort of like palladium because nickel is very often used to get a whitish color on gold, sometimes silver, but they say that palladium is preferred because nobody's allergic to palladium. This is one of their jewelry items with 14 karat palladium, and that's the jewelry. Let's go back to the FRQ. The atomic rating of the metals is given, and as we expected, they're the same. Now, here's the problem. A particular ring is made of an alloy of 75 mole percent gold. The carat ones are by weight, and 25 mole percent palladium. Using the box below, draw a particle level diagram of the solid alloy consisting of 12 atoms. So we've got to draw 12 atoms with a representative portion of atom types. Your diagram should clearly indicate whether the alloy is interstitial or substitutional. Use empty circles for gold and shaded circles for palladium. Okay, what do we got to know to be able to answer this? Well, there's a couple of important things here. The first is that this is a solid, so we'd expect the atoms to be arranged in a regular rather than a random liquid manner. The second thing is this term interstitial and substitutional. Well, back to my flashcards. Here in AP09, I show the difference between interstitial alloys and substitutional alloys, cards 112 and 113. There are 44 pages in these outlines. There's quite a few little tips, but it's an entire course all by itself. Interstitial, we've got a regular solid lattice where you've got these regular arrangement. The interstitial has the impurity, in this case the palladium, messing up the arrangement, while substitutional, it has the atom inside the arrangement as part of the lattice. So this is between the atoms, inter, and substitutional is substitutional. That's pretty easy to figure out. Both these tend to have slightly different sizes in atoms. Typically, the interstitial alloy atoms are very small. The substitutionals tend to be about the same size, but enough difference in size so that's harder for these atoms to slide by one another. So both these will make an alloy a bit tougher than the original usually. That's the AP chemistry explanation. It's not really a good explanation, but for AP, we'll use 12 atoms in a regular arrangement. And in this case, because the atoms are the same size, we're going to guess that they're going to be substitutional, which it usually is. So here would be our 12 atoms that we've got drawn in. We've set them up as a regular arrangement rather than a liquid, about the same size. You're not going to be able to differentiate 135 from 140. We've got those two parts taken care of. Now the next thing is it is 75 mole percent and 25 mole percent. Those are numbers of atoms, and 12 atoms, 1/4 of them are palladium, so the shaded one's supposed to be palladium, so 1/4 of 12 is 1, 2, randomly arranged 3. I guess I could have made this one over here. No, that's pretty random. We've done it. Let's see. Your diagram should indicate whether the alloy is interstitial or substitutional. Substitutional because of the same sizes. Crossed fingers on that. But that's what they wanted. Empty circles for gold, which is 3/4 of these 12. And the shaded circles, 4 goes into 12, 1/4, 3 of them, 1, 2, 3. So that would be this A. Here's the scoring. 1 point, same size, substitutional, rather than in between the lattice. And I'm not sure I could possibly get it in between anyway. And 1 point for the correct number of each element. That's pretty easy. So we've got 2 out of the 4 points. I think the average on this was like around 1.5, so you're better than the average student. Let's go on to the next question, or the next part. White gold jewelry is often coated with rhodium to modify the color and durability. A student hypothesizes, okay, it's another student question, that placing a ring in 1 molar solution of rhodium nitrate, okay, rhodium +3 soluble, will result in a reaction where the rhodium metal is deposited on the white gold ring. Based on the information in the table below, calculate the standard voltage for the reactions that may occur between the ions in solution and the atoms in the ring. Indicate whether or not the student's hypothesis is correct. Now we have to do 2 things. Calculate the voltage and indicate the hypothesis as being correct. And the hypothesis is that this reaction will occur. Well, the reaction is with rhodium. Okay, this one, I say, wait a second. But they give us these voltages here, so that's going to help us. The reaction is rhodium plus 3 turning into rhodium. That part we can sort of figure out. Let's deal with the gold first. We've got the rhodium here and the gold. Now they want the rhodium to plate out, so that means the gold has to oxidize. If the rhodium reduces, the gold oxidizes. So in this case, it's a 1-to-1 reaction. So this is what you had to figure out. And looking at the voltage chart, you say, wait a second. Usually the top material reduces, but here they've got the top material gold oxidizing, going backwards. This isn't going to happen. I would immediately say the student hypothesizes incorrectly. Answer that, and even if you don't have the voltages right, you would end up probably getting the point for this. But we have to get the voltages. Now, the only equation we've got for voltages is reduced substance minus the oxidized substance's voltages. Well, in this reaction, they've got the rhodium reducing, which is 0.76 volts. That's what they say is going to be happening. Of course, if the rhodium reduces, the gold's got to oxidize, which is 1.5. So in this equation, we're going to have to say it's the rhodium, 0.76, minus the gold, and that gives you a negative voltage, and negative voltages don't happen. That's a positive delta G. Now, your gold is safe. It's not going to be plated with this rhodium, which is, I think, inferior to the gold. So at least that part's wrong. But we have to get both voltages. The next reaction is going to be the same, except they're going to be using palladium, and same thing. Palladium's above. Palladium's not going to go backwards, and the rhodium is not going to go forward because rhodium doesn't have enough of a reduction potential. Rhodium ions aren't good enough at grabbing electrons. They're not going to rip electrons off of palladium, nor are they going to rip it off of gold. So this reaction, where rhodium ions grab electrons, reduce, gain electrons, the palladium, is not going to happen. And we just need to get that voltage number. And again, it's just that simple subtraction that you can probably do with your calculator, and I'm not going to bother doing that with my calculator. So we've answered the question. That's the 4 points. That's it for FRQ 4. You get 1 point for the voltages, 2 calculations, just a couple of simple subtractions, but you have to have that negative sign there because this is going to happen, and 1 point for the claim. Don't forget, you have to say this is not going to happen. In fact, let's see. Do I have that? Yes. Student hypothesis was incorrect, and you have to do both things. If you just showed the voltages and didn't say student's wrong, you lose that important point. So get that extra point. You did the work for the voltages. Answer the question. Answer the question. Remember, here it says, do the voltages and indicate whether or not the student's hypothesis is correct. You have to do both. Question number 4. So stay tuned and pick up the next video, which is question number 5. It has some very interesting parts to it. So subscribe, and go on to 5 and learn how to do these FRQs so you can ace that AP Chem exam. This is golden.